Well, hey there, guys. Now, today we're going to have a look at set notation. All right, and there's a few things that we're going to go through. We're going to have a look at some different types of numbers, and we're going to have a look at some different symbols and meanings of these things when we go through and we have a look at what set notation is. All right, so let's first of all have a look at what actually is set notation. Now, sets are a collection of things. So these can be schools, they can be numbers, they can be planets, they can be anything that you can collect in a set. For example, I used to collect Tarzo and Pokemon cards. That is a set. You could talk about those as being sets. And we can show sets like this as well, where you've got Venn diagrams. There's a number of other different ways to show sets, which you will see throughout the course of this topic and also throughout the course of probability. Alright, so let's first of all talk about numbers as being sets. Now, we can describe all numbers as a set. Alright, and we're going to talk about that, and we're going to put all these numbers in this box here. Now, the very first set of numbers is natural numbers. Now, these numbers are things like 1, 2, 3, 4, and so on. Alright, so that's basically the numbers that you would use to count in 40-40 or hide and seek, any of the normal natural counting numbers, and that's why it's called natural numbers. Now, the next type of set of numbers, or the next set of numbers, are called integers, and they're denoted by the letter Z. Now, if we have a look, integers are things like 0, -1, -2, -3, and so on as well, going down in the negative direction. But they also count these ones here, the 1, 2, 3, and 4. So integers are all of the negative numbers plus all of the natural numbers. Now, the next type of number is called rational numbers, all right? And that's denoted by this letter Q here. Now, rational numbers, as we know, numbers don't just exist between the whole counting numbers and the integers. There's actually numbers in between them, and we can represent these numbers in between them using fractions like 1/2 or 2/3 or -5/6, because of course it can be negative as well, or 7/8 or even -1/5, all those things. So if we can write a number as a fraction, it's a rational number. Now, we know if it's rational because the rational numbers will end up repeating their decimal places eventually. So, for example, 1/3 is 0.33333 repeated, and it just keeps going on and on and on. That's a rational number because the 3 repeats. Now, for every single fraction, you will end up getting a repeating of the decimal numbers that you can see. Now, it might be 0.16161616, but eventually those numbers will repeat, and it might take 10 numbers or 10 decimal places for it to start repeating, but any number that you can write in a fraction will eventually end up repeating, and that's why it's called a rational number. Now, the next one, and also rational numbers include integers and natural numbers as well. So, of course, rational numbers are fractions, but they're also all of these numbers in here too. Now, the next one is irrational numbers. So, if you've got rational, the opposite is irrational. And irrational numbers are these special ones like surds or like pi, or once again another surd, a negative version of it. The thing about these irrational numbers, these decimal places don't ever repeat. They're just randomly placed. So you just get, it might be 0.9256349649392179886. Alright, it just ends up going on and on and on, and the decimal numbers don't ever fall into a pattern. It's just random. And hence pi, it's such a big important, such an amazing thing for people to remember pi, because that goes on forever and ever, and it doesn't stop and it never repeats itself. So we can talk about all of these types of numbers as being real numbers. Now, real numbers are really natural numbers, as well as integers, as well as rational numbers, as well as irrational numbers, all come together, and any number that you can ever think of is a real number. Alright, so let's have a look now at some of the different types of symbols and terminology you're going to come across when dealing with set notation. Now, the very first thing is this one here. Now, if you see little squiggly brackets like this, it means it's a set. Alright, so let's just say this here is set A and this here is set B. So set A is 2, 4, 6, 8, 10, 12. These dots mean that the set continues on along with that pattern. And same with this one here for B, it's -2, -1, but 0, 1, 2, but it means that it also goes all the way down to -infinity and all the way up to infinity because of these dots here. But they only include, it's essentially just integers for this one. Alright, when referring to sets, we can actually give them a name, such as like a capital letter A or B, like you've got here. And yeah, like I said, those dots really, they show you that they go on forever. So these are sets. Now, an element of a set is something that's within that set. So for example, here, 2 is an element of A. And for this one here, you can see that 2 is an element of this set because 2 is in here. An element of B might be a negative 100 because you know here it goes all the way down to negative 100. Alright, for this one, if it's got an element symbol but it's got a line through it, it means it's not an element. So if we have a look here in this example, you can see that 3 actually isn't an element of this set here because 3 is not actually in it. Now, this one here is a bit of a harder one that people generally struggle with, and that is this symbol means it is a subset of. Now, subset of means that everything in the set N is also in Q. So let's have a look at that. Are all the natural numbers also within the irrational numbers? Sorry, let's have a look at that again. Are all the natural numbers in the rational numbers? Well, yes, they are, because all natural numbers are also known as being rational. So N is a subset of Q because all of these are found within this section here. But this one here where it's got a subset but the line through it, meaning not, this line essentially going through anything means not, and you might have seen that is not equal to. This here means that it's not a subset of. So the natural numbers are not a subset of irrational numbers, because if we have a look here, these numbers here do not have any overlap with these numbers here. Now the next definitions on the other types of symbols that you're going to come across are things like excluding. So for example, if I have A is equal to 1, 2 and 3 as a set, B is equal to 2, A excluding B means all the elements that are in A but aren't in B. So if you have a look here, 1, 2 and 3 is in A, 2 is in B, so that means we cancel out the 2 in A, and that leaves us A excluding B is equal to 1 and 3. Now, intersection is shown by this upside down U or an N or something that looks a bit like that. And the intersection means any overlap that they have between the two of them. So, for example, the set here, T is equal to Thomas or THOMAS, and V is equal to AEIOU, being the vowels. Now, T intersect with V, what ones do these have in common? Now, you can see here that it's got an O and an A, and I've just put that in alphabetical order there for you. So, T intersect with V is A and O. The union with, however, means all of the elements in one set combined with all of the elements in another set, but we don't repeat any ones that are overlapped or doubled up. So, if we have a look with this, we've got A is equal to 1, 3 and 5, B equals 1, 2 and 3. A union B, so that is all the elements in this as well as all of the elements of this with no double ups, is 1, 1's doubled up, so we'd only write it once, 2 goes here, 3 goes here, and 5 goes here. So that's all of these elements without any double ups. And then finally, the null set or an empty set is a set with no elements. Now let's just have a think about this for a second. If we have a look at the integers and we want to see whereabouts they intersect with irrational numbers, well, do the integers and irrational numbers intersect? Well, they don't at all. So therefore, this is what we call a null set, and we denote that by actually having like a 0 with a line going through it.